Hi, welcome back to Science 1206, the motion unit. I'm Ms. Ledwell, and in this video, we'll go through acceleration, time, and velocity practice problems. Let's begin. Before we start the problems, please pause this video and grab a pencil and some paper, ideally, or you can open up a blank document on your electronic device. As the next slides are revealed, try the problems on your own. We will then review the answer together. After collecting your writing supplies, please resume this instructional video. Practice problem number 1 says, a car driving eastward is accelerating at a rate of 2.50 meters per second squared. If its initial velocity is 25.0 meters per second, what is its velocity after 33.50 seconds? Pause the video now while you work through the answer, and then resume the video and we'll go through the answer together. The first thing you should have done is figured out the information you were given in the problem. You were given that the acceleration is 2.50 meters per second squared. You were given that the initial velocity is 25.0 meters per second east. And you were given that the time is 33.50 seconds. You are asked to find the final velocity. It says, what is its velocity after 33.50 seconds? So at the end of the time interval. For my solution, the first step is to write the equation to solve for final velocity, which is v2 equals v1 plus acceleration times time. Next, I'm going to put in the information from my given into the equation. Then I'm going to calculate the answer, and I remember that I need to use order of operations here, so I do my multiplication before my addition. When I multiply 2.50 times 33.50, I get 83.75. This answer should have 3 significant digits, the same as the least, but remember, I save that step till the end because I don't want rounding errors. So now I'm going to add, and I get 108.8 meters per second east, so my answer should have the same number of decimal places as the least in my equation, which is 1. So my answer should have the same number of decimal places as the least number in my equation because I'm adding, and that means 1 decimal place. Let's try another one. A cyclist has an average acceleration of 0.50 meters per second squared. How long will it take them to reach a velocity of 13.5 meters per second forward if they start from 1.0 meters per second? So your first step is to pick out the information you're given in the problem. You're given that the acceleration is 0.50 meters per second squared forward. The initial velocity when they started was 1.0 meters per second and they were going forward. And the final velocity was 13.5 meters per second forward. You're asked to find the time. How long does it take means find the time. For your solution, your first step is to write down the equation for solving for time, which is delta t equals v2 minus v1 divided by a. Next, you put the information in your given into the equation. So we have 13.5 meters per second forward minus 1.0 meter per second forward divided by 0.50 meter per second squared. And our answer, with the correct number of significant digits, is 25 seconds. Let's try another problem. A scooter moving north at 14.0 meters per second experiences an acceleration of 2.0 meter per second squared north. What is the velocity of the scooter after accelerating for 4.0 seconds? Our first step is to pick our given information from the problem. We're given that the acceleration is 2.0 meters per second north. We're given that the initial velocity is 14.0 meters per second. And even though it doesn't say velocity, I know this is velocity because of the units, meters per second. And we're given the time is 4 seconds. We're asked to find the final velocity. What is the velocity of the scooter after this period of acceleration? For a solution, your first thing you should do is write down the equation for final velocity, v1 plus acceleration times time. Next, put the information in the given into the equation. 14.0 meters per second north plus 2.0 meter per second squared north times 4.0 seconds. Remember your order of operations. Do your multiplication first. That gives us 14.0 meters per second north plus 8.0 meter per second north. Our final answer then for final velocity is 22.0 meter per second north. Next, let's look at practice problem number 4. A skateboarder moving at a constant velocity heads towards a ramp where she accelerates at a rate of 0.75 meters per second squared towards the east for a duration of 4.0 seconds, reaching a new velocity of 6.0 meters per second towards the east. Determine the initial velocity of the skateboarder. Our first step is to pick out the information we're given in the problem. We're given that the acceleration is 0.75 meters per second east. We're given that the final velocity is 6.0 meters per second east, and that the time is 4.0 seconds. We're asked to find the initial velocity. Our first step is to write down the equation to solve for initial velocity, which is v1 equals v2 minus a times t. Next, we put the information from our given into the equation, and we have 6.0 meters per second east minus 0.75 meters per second squared east times 4.0 seconds. Remember to use order of operations, which means we do our multiplication first. So now we have 6.0 meters per second east minus 3.0 meters per second east, and that gives us a final velocity of 3.0 meters per second east. Now we're on to our last problem, number 5. A car moves in a straight line at a constant velocity of 30.0 meters per second forward for 8.0 seconds. What is the car's acceleration? In this problem, given that the car is moving at a constant velocity, meaning its velocity remains unchanged, the acceleration of the car is 0. This is because acceleration is defined as the rate of change of velocity over time. And with no change in velocity, the acceleration then is 0. Now it's time to continue to the next video. Let's break for a stretch first. Take 30 seconds to refresh your body and mind, then continue on to the next instructional video.